This video is part 2 of 2 learning objectives for this unit work you've already copied down when you were doing part 1. Over this next section we're going to look at work where we're going to be dividing by infinity. So a number is going to be divided by infinity, and we need to have a thorough understanding as to what this means before we can go on to solve problems. So what we have here is we're going to look at 5 divided by 1, which is simple. 5 divided by 1 is equal to 5. Now we're going to increase the bottom of this fraction by a factor of 10. So we've now made the bottom bigger. 5 divided by 10 is 0.5. Then we make the bottom bigger again. 5 divided by 100 is 0.05. And then we make the bottom bigger again. Let's just pause and look at what's going on. We're now divided by a much bigger bottom, which is going to be 100,000, and the answer is much, much smaller. And as the denominator gets larger, the value of the fraction gets smaller. As the denominator, the bottom number, gets larger, the whole fraction gets smaller. And that leads us to a very, very important concept. As the denominator tends to infinity, the value of the fraction itself tends to 0. So if we have a number divided by infinity, then we're saying that that number is tending to 0. So, in mathematics sense, how do we write that? The limit as n tends to infinity, where k is a number, being divided by this n, which is tending to infinity, then we know the answer will be equal to 0. So in our heads, what we're doing is we're substituting for the value of n, we're putting it equal to infinity, and we already know from the working out above here, as a denominator tends to infinity, the fraction tends to 0. So there's the denominator becoming infinity, and therefore the whole fraction is now going to be equal to 0. Another very, very important concept which you must learn, that if you've got the n on the bottom and it's been raised to a power, as long as that power is bigger than 0, very important, power is bigger than 0, it's still going to be equal to 0. And this symbol here is the upside down a, means for all, or for all values of. So now we're going to go on to a different case. And this case is where we have an infinity over an infinity. So what we do here when we're solving this, now I'm going to do it, but we don't actually do it. We just take note. We substitute in infinity in our heads, and we get infinity over infinity plus 1. Well, infinity plus 1 is equal to infinity. And consequently, we've got the ambiguous case, infinity over infinity. So we don't know what's going on. So as soon as we get that, we get rid of it again. And we say, right, what's the method? And the method, which you should pause the video and write down these 5 points, is that you fully divide top and bottom by the highest power of the variable given in the question. Well, in the context of this question, the variable is in actual fact n. So therefore we're going to be dividing top and bottom by n. So we're going to have n divided by n on top, and on the bottom we're going to have n divided by n plus 1 over n. We're then going to tidy this up, so we have the limit as n tends to infinity, and the top is going to be 1, n over n is 1, n over n on the bottom is 1, plus 1 over n. And then at this stage we could sub in, so we're going to have 1 over 1 plus 1 over infinity. Well, we know from the previous page that 1 over infinity is in fact equal to 0. So we're going to have 1 plus 1, 1 over 1 plus 0. So we're going to have 1 over 1 plus 0. The answer is going to be 1 over 1, and the answer is going to be 1. And here we go again. When we put infinity in, we're going to have 2 lots of infinity squared, which is just going to be infinity. And we're going to have 3 lots of infinity squared on the bottom, which is just infinity. So we've got infinity over infinity again. So we're going to get, when we substitute infinity in for n, infinity divided by infinity again. So as soon as we do that, we're going to be using this line here. You must fully divide top and bottom by the highest power of the variable. Well, the variable in this case is going to be n, and the highest power of this variable is going to be n squared. So just rewriting this line, so we've got the limit, so this is equal to the limit as n tends to infinity of, well, we're going to have 2n squared divided by n squared plus 15n divided by n squared minus 1 over divided by n squared. So we've divided every term on top by the highest power of n. And now we're going to do that same thing on the bottom. So we've got 3n squared divided by n squared minus 3n divided by n squared plus 2 divided by n squared. So we're dividing top and bottom by the highest power of n, which is going to be n squared. When we do that, the n squared here and the n squared there cancels there as well. One of the n's on top cancels with one of the n's there, one of the n's on top, one of the n's there. So this becomes a rewrite line. So we've got equal to the limit as n tends to infinity of 2 plus 15 over n minus 1 over n squared. And then on the bottom, we're going to have 3 plus 3 over n plus 2 over n squared. Now, what do we know from the previous page? Well, what we know from the previous page, that any number over infinity, and don't forget, when we substitute in here, that's going to be infinity. This is going to be infinity squared, so it will be infinity. This will be infinity. This will be infinity, because n is tending to infinity. Well, what's 15 over infinity? Well, we already know the answer to that. 15 over infinity is 0. So on top, when we substitute in, we're going to get 2 plus, what's 15 over infinity? We can do this in our head. 15 over infinity is 0. What's minus 1 over infinity squared? Well, it's 0. Anything with just infinity on the bottom becomes 0. So therefore, this one's 3 over infinity, 0, plus 2 over infinity squared, 0. So therefore, the final answer is 2/3. Some of you might spot that's the same as the number at the front of the n squared and the number 3. And that will always be the case, to be honest with you. But if you do not show this working out, you will get 0. Absolutely guaranteed. Anytime you want to pause the video and stop and take notes, copy down key points is essential into your copies, then please do so. Now, the next limit, we can't actually do it because something's in a square root and something else isn't. So the easiest way of solving this particular problem here is to put everything inside a square root. So what I need to be putting inside a square root is n squared plus 2. But in mathematics, when you put something inside a square root, then you have to square it first. So I'll give you an example. If I want to put 3 inside a square root, I have to square it first. If I square 3, I get 9. What's the square root of 9? 3. So if something is not in a square root and you want to move it into a square root, you have to square it. So therefore, because I want the square root symbol surrounding everything, I have to square the bottom. So therefore, n squared and n squared is n4. N squared on 2 plus 2n squared. 2 on n squared plus 2n squared. 2 on 2, 4. Tidy up line, we end up with n to the power of 4 plus 4n squared plus 4n squared plus 4. So we can now progress this to the next bit, next line. So the limit as n tends to infinity of the square root now of the whole thing. Well, on top you've got 5n4 minus 3, and on the bottom you've got n to the 4 plus 4n squared plus 4. And again, in order to solve this problem, we're going to have to divide top and bottom by the highest power of n. And the highest power of n, in this case, is n to the power of 4. So let's just do that here. So we've got 5n4 divided by n4 minus 3 divided by n4. And that's all going to be divided by n4 divided by n4 minus 4n squared divided by n4 plus 4 divided by n4. And that whole expression is inside the square root symbol. So we've now got equals the limit as n tends to infinity. Right then, 5n4 cancels. That's nothing cancelling there. That cancels and leaves a 1. N squared cancels with 4 on the bottom to leave a power of 2, and that one stays the same. So now we need to rewrite it here. The limit as n tends to infinity of square root symbol, which goes a lot across lots of spaces. So it's going to be 5 plus, beg your pardon, minus 3 over n4. All divided by, well, n4 divided by n4 is 1. 4 divided by n squared. And that's going to be plus 4 divided by n4. And once again, we're going to have the limit as n tends to infinity of the square root of, well, 5. N tends to infinity, so minus 3 over infinity is minus 0. On the bottom, we've got 1 minus 4 over infinity squared, which means it's going to be 0. And 4 over infinity to the power 4 is going to be 0. So the answer is the limit as n tends to infinity is going to be equal to 5 over 1, which is square root of 5. I would remind you that any time you want to pause this video, you can. Okay, this is called a piecewise function. and we're going to take it bit by bit. Let's pay attention to the information up above. Now we're going to look at the limit when we are analysing x tending to -2. So we're looking for the bit over here which contains -2. So it must be for x is less than 1. That's anyway, -2 is less than 1. So they're now telling us to use this formula in our calculation. So for part 1, we're going to have the limit as x tends to -2 of 2x plus 3. And then we substitute it in, so it's going to be 2 on -2 plus 3, which is -4 plus 3, which is -1, and the modulus of -1 is 1. So that's the first one done. We're now looking at the second problem, and the second problem is looking at x is greater than 2. So which of these two x values gives 1 greater than 2? It's this one. So now we're going to be using this formula. So for part 2, we're looking at the limit as x tends to 2 for f of x, and it's the yellow version, so it's going to be 2x minus 3. So that's now going to be equal to 2 on 2 minus 3. 2 2's are 4. 4 take 3 is 1. And that's the end of that one. So we're now going on to example number 3, and it says x equals 1. Now you think you're going to be using the yellow for this, and you'd be wrong, because x, don't forget, x tending to 1 is moving closer and closer to it. It isn't necessarily equaling it. So the reason why this is a trick question, the limit as x approaches 1, is because you're using both of them. So we've got f of x for the top one is 2x plus 3, and for the bottom one, f of x is equal to 2x minus 3. The test value is x is equal to 1, so we're looking at x is equal to 1, or well, it tends to 1, so we put it equal to 1. So that's now going to be 2 on 1 plus 3, so the answer is going to be 5 units on the y-axis. X tends to 1 here, so we've got f of 1 is equal to 2 on 1 minus 3, so f of 1 is equal to minus 1. Because these two limits actually don't match, because the function, no matter which one you're using, if a limit exists, then these two numbers should match. They don't match, and so consequently we can actually say there is no limit. So don't forget, if you've got a piecewise function and the borderline is given in the limits, because the borderline for less than 1 and equal to 1 is 1, then you can say it has no limit. Now, university, what they'll say is it has a limit when it approaches from the left, and that limit is 5, and it has a limit when it approaches from the right, and that limit is minus 1. But for here, if they don't match, we just say no limit. For our course, it has to be the same value, no matter which side you come at it from. This is a summary table of all the results. If you end up with a number over a number, well, it has a limit, and it will be whatever the number is over whatever the number is. If you've got a number over infinity, it has a limit, it's defined as 0. If you've got infinity over a number, there's no limit. If you've got infinity over infinity, not sure, so therefore you have to follow the method indicated below it. If you've got naught over a number, that is defined, and the answer is 0. If you've got a number divided by 0, all the way up to junior cert, junior cycle, you've been told you can't have a 0 on the bottom. That's not defined, there's no limit, so it'll go on to infinity. The last one, it actually says to you 0 over 0, and we're just not sure. It's an ambiguous case. It's like the infinity over infinity. You follow the method outlined below. So please pause and copy this down. It is extremely important.